The first question that I want us to think about is this one, f of x equals, and it's a piecewise, x squared plus 3 if x does not equal 1, and it is just 1 if x does equal 1. And so in this problem, they ask us to find the limit as x approaches 1 of f of x. So remember that in order to find the limit as x approaches 1, we need to look from both the left and we need to look from the right. And if they're the same, then our limit exists. If they're different, then our limit does not exist. So from the left-hand side, so that's values less than 1. So we're going to use this definition here because this is for values x less than 1. We would use this top definition. So we're going to get 1 squared plus 3, which is 4. And from the right, we want values greater than 1. So that's also going to be this definition right here. We're going to also use this for x values greater than 1. So it's the same exact definition. So obviously we're going to get the same answer, and our limit is 4. So compare that. If I want to just find the limit, that's what I do, and I'm done. Compare that to a question that asked, is the function continuous at x equals 1? For continuity, we need to look at 3 things. We need to look if the limit exists, so the limit from the left, does it equal the limit from the right? And then we need one more thing. We need to find the function value at that point. And if all 3 of these are equal, then it's continuous. If not, then it's not continuous. So we know the limit from the left was 4. We know the limit from the right was also 4. And what is f of 1? F of 1 is actually this definition here, right? Because we use this at x equals 1. So that equals 1. So they're not all the same, therefore not continuous at x equals 1. I should say f of x is not continuous at x equals 1. I want to look at number 10, and I want to do this problem 2 ways. So this problem is asking the limit as x approaches 0 of root 4 plus x minus 2 all over x. Whenever I have something that's approaching 0 and I also have it just over itself, it looks a lot like my limit as h approaches 0 definition of f prime of a, right? F of a plus h minus f of a all over h. So I'm thinking maybe I can solve this one this way, but I'm not positive until I'm sure that it actually fits its definition. So does it? I have to ask myself that question. Let's see. If this is f of a plus h, then I have the square root of a plus h. So our a would be 4. And what am I doing to the a plus h? I'm square rooting it. So my f of x would be square root of x. And how do I check that this actually fits the definition? Well, if it fits the definition, then this should be my f of a. That should match up with this. So f of a in this case is f of 4, which is root 4, which is 2. Yep, it does fit this limit definition here. So what I'm going to do is say that this thing is equal to f prime of 4, where our f of x is square root of x. So if f of x equals x to the 1/2, then f prime of x is 1/2 x to the negative 1/2, which would mean that f prime of 4 would be 1 over 2, and then I put that root 4 in the bottom here, right? So I have 1 over 2 times 2 is 4. So our answer would be 1/4. Now, I said I'm going to do this 2 ways, because the other way to do this problem would be to multiply by the conjugate if you didn't see this relationship here. So how does that work? I do my limit as x approaches 0, root 4 plus x minus 2 over x, going to multiply by root 4 plus x plus 2 over root 4 plus x plus 2. And I'm going to get the limit as x approaches 0 of 4 plus x, right? Because root 4 plus x times root 4 plus x is just 4 plus x. Then the outer and the inner are obviously going to cancel out when I FOIL. Minus 4 is my last term all over x times 4 plus x plus 2. So now if I simplify the top, I'm just going to get 4 minus 4 is 0, so I'm just going to have an x on the top. And I'm going to leave that whole thing on the bottom and never distribute it, because hopefully something's going to cancel out, which it does in this case. That x is going to cancel out with that x. And so I'm going to be left with a 1 on the top, and then I can plug the 0 in now. So I have root 4 plus 0 plus 2, which is 1 over root 4 is 2. And look, I also get 1/4. So either way, I'm going to get the same answer. It just depends on what you see in this problem. Now I'm going to look at number 12, which is asking me the limit as x approaches infinity of 3 plus 2x squared minus x to the 4th all over 3x to the 4th minus 5. Whenever you're doing a limit as x approaches infinity problem, you need the denominator to approach a finite value. So you divide by the highest power of x in the denominator. You divide everything. And so I would get 0 plus 0 minus 1 over 3 minus 0, or negative 1/3. This question here just asked me to find the limit as x approaches infinity, and so I did. I could also ask you to find a horizontal asymptote of the equation that I gave you, and you would need to know to set up a limit as x approaches infinity, and you would have given me that horizontal asymptote of y equals negative 1/3. Remember, that's how we find horizontal asymptotes, is we find the limit as x approaches infinity. So since we're talking about that, let me go ahead and do number 14, and I can explain what I mean. So if I have an equation like f of x equals x squared plus 5x plus 6 over x squared minus x minus 12, and say on the exam I asked you to find the horizontal asymptotes and the vertical asymptotes, because I might just do that. This is exactly how I want you to solve the problem, and this is how much work I want you to show, the level of detail. So to find the horizontal asymptotes, technically you need to look at the limit as x approaches positive and negative infinity. The negative infinity really comes into play if you have an e to the x one, because it looks very different on the left and the right. Most of these functions that we deal with are going to look the same on the left and the right. So for this case, for horizontal asymptote, you just need to look at the limit as x approaches infinity. But to get full credit for showing your work, for finding the horizontal asymptotes, I need to see that you actually looked at the limit as x approaches infinity. If you just tell me an answer, you won't get full credit. So to find horizontal asymptotes, always look at the limit as x approaches infinity, and that means divide by the highest power of x in the denominator. So in this case, we have 1 over 1, which is just 1, but that's not an answer to my horizontal asymptote. My horizontal asymptote is at y equals 1. To find vertical asymptotes, what you want to do is you first want to factor your equation down, because remember, if something crosses out, then it's a whole and not an asymptote. So in this case, I have x plus 3 and x plus 2, and on the bottom, I have an x and an x, a 4 and a 3, a negative and a positive. So the 3's cancel out, which indicates that I have a whole at x equals negative 3. That is a removable discontinuity, at x equals negative 3. And then I have my vertical asymptote here. My vertical asymptote is at x equals 4. Okay, so if I ask you that question on the exam, I need that level of detail on your response. Now let's take a quick look at 17, which is another limit as h approaches 0, 1. Cubed root of 8 plus h minus 2 all over h. On this one, I can't really do anything easy except recognize that this is the definition of f prime of a. Because I can't just multiply by the conjugate since I have a cubed root here. So my f of x would be the cubed root of x. And what am I doing? A plus h. So my A is 8. Let's just check and make sure it's of the proper form. So this should be my f of 8, hopefully. So the cubed root of 8 is 2. Yep, that is right. So to solve this question here, I would do f of x equals x to the 1/3, which means that f prime of x equals 1/3 x to the negative 2/3. And so I'm doing f prime of a, which is 8, 1 over 3, 8 to the 2/3, right? Now always break it down before you build it up. So 8 to the 1/3, the cubed root of 8 is 2. So 1 over 3 times 2 squared. 1 over 3 times 4 is 1/12. On number 18, they didn't ask you to solve, but I am going to ask you to solve that one now. So I have 2 plus h to the 5th minus 32 all over h. So I'm thinking that my f of x is 2 plus h to the 5th power, so something to the 5th power. And my a is 2 plus h, so probably 2. Let's check it out. F of 2 is 2 to the 5th, which is 32. Yep, that is right. So that is of the proper form. So f of x equals x to the 5th means that f prime of x is 5x to the 4th. And in this question, I'm doing f prime of a, which is 2. So f prime of 2 is 5 times 2 to the 4th. So 2 to the 4th is 16, and 5 times 16 would be 80. So that would be my answer. Now I want to turn to question number 30, and that one was based on a table of values. And so in this problem it said find h prime of 1 if h of x equals f of g of x. And so if h of x equals f of g of x, that g of x is my baby there, then h prime of x is going to be f prime of box times the derivative of the box, which is g prime of x. So that's just a chain rule. And so h prime of 1 is going to be f prime of g of 1. Then I have to look at my table. I see g of 1 is 2 times g prime of 1. F prime of 2 is negative 1, and then g of 1 is also negative 1. Negative 1 times negative 1 is simply 1. So that's that. For question 31, it asked me find h prime of 2 if h of x is x f of x squared. And so this is x times f of x squared. So I do need a product rule. This is my first, this is my second. So h prime of x is the derivative of the first, which is 1, times the second, plus the first, just x, times the derivative of the second. So the derivative of f of x squared, that's my baby, f prime of x squared times the derivative of the baby, times 2x. So that's the derivative of the second. And so now to evaluate h prime of 2, I just plug in a 2. So I have f of 2 squared is 4, plus x is now 2, f prime of 4, and 2 times 2 is 4. So that's f of 4 plus 8, f prime of 4, which is 5, plus 8 times f prime of 4 is simply 1 from the table, so I get 13. Now I just want to extend on 2 more things. I want to find h prime of 1 if h of x is 5 f of x plus 1. So h prime of x in this case is going to be, this is just a constant, the 5, so 5, and the derivative of f of x plus 1 is f prime of x plus 1 times the derivative of the box, which is simply 1 in this case. So I just have h prime of 1 is going to be 5 f prime of 2 times 1. And f prime of 2 in my table is negative 1. So that's going to be 5 times negative 1 times 1, which is negative 5. The next one I want to do is h prime of 1 if h of x equals f of x to the fourth. And so if h of x equals f of x to the fourth, then h prime is going to be, that's my baby, right? F prime of x to the fourth times 4x cubed. And so h prime of 1 is f prime of 1 to the fourth, which is 1, times 4 times 1 cubed. F prime of 1 is 1. And then I have times 4, which is just 4. And then the last one that I want to do of this kind is h prime of 1 if h of x equals f of x, the whole thing, to the fourth power. So here I would have h prime of x, this is my baby. So I have box to the fourth power. 4 box cubed times the derivative of the box. So that's the derivative of f of x is f prime of x. So h prime of 1 is going to be 4 f of 1 cubed times f prime of 1. F of 1 in my table is just 3. So 4 times 3 cubed. And then f prime of 1 is just 1. And that answer should be 108. Now let's go ahead and look at 32, which is asking us a limit as h approaches 0 of sine 2x plus h minus sine 2x all over h. And you should be thinking to yourself, this might be a limit as h approaches 0. Definition of f prime of a problem. Let's see if it is. And the key there is just that I'm doing a limit as h approaches 0, or I could have an x approaches 0, and I just have this x or h on the bottom. They're usually of that form. So let's see if this works out for us. So in this case, our a plus h, our a would be an x. I know it looks a little weird, but just bear with me because that's what I'm adding to the h. And then my function would be, what am I doing to my a plus h? I'm doing sine of 2a plus h, so it would probably be sine of 2x. I have to check if this is actually my f of a, so f of a would just be, replace the x with the x. It's the same thing, right? So sine 2x, yep, that does work. And so if f of x equals sine 2x, that's my baby, right? F prime of x is going to be cosine of 2x times 2, because the derivative of sine is cosine, and then I need to chain it. And so my answer here would just be 2 cosine 2x. That's my answer to this problem here. Okay, let's go ahead. Here's a graph of f, and let's talk about a couple of things. And excuse my handwriting. My handwriting on this tablet is terrible, so just putting that out there ahead of time. So let's talk about some things about this function. Here's the graph of f. And so if I asked you, for instance, where is the derivative positive, okay? That's the same thing as saying, where is f increasing, correct? So f prime is positive where f is increasing. In this graph, that's from -2 to 0. And don't worry about open or close intervals. Let's just make them all open. So -2 to 0, and then also from 2 to 4. And now, what if I asked you, where is f double prime positive? Well, that means where f is concave up, right? So where is f concave up? It's concave up from -4 to 0. Isn't it concave up the whole time there? Yeah. What else could I ask you? I could ask you, where is f prime actually equal to 0? F prime equals 0 right here at x equals -2. Just to make sure that you're getting this, let me just draw something, and then I'm just going to make up some points. So I'm going to make this point A. I'm going to make this point B. I'm going to make this point C. And I'll make this point D. So let's see, where is F positive? F would be positive just at the point A, right? Because the function's only positive here and here. Where is F prime positive though? F prime is positive if the slope is positive or if F is increasing. And that would be only at point D, right? And what about F double prime positive? F double prime positive means that F is concave up, right? And where is it concave up? It's probably concave up right here at C and at D. I think point B might be my inflection point. I'm just going to make a note. It's an inflection point on my function. So I would say it's concave up at points C and point D, because I would say it's concave up probably somewhere from here to here or so. What else do I know? So we knew that we have a minimum at C, and so F prime equals 0 at point C. And then what does this mean? I have an inflection point here, so that means I'm changing concavity. I'm changing from concave down to concave up at point B. So that would actually mean that F double prime equals 0 at B, because I see an inflection point there. So those are just some little review things. Let me take you real quickly to this graph right here just so we can discuss it. So if this is the graph of F, then where is F prime not defined? That's the same thing as saying where is F not differentiable. So if I ask you where is F not differentiable, it's not differentiable at B because that's a corner. It's also not differentiable right here at 0 because that is also a corner. It's not differentiable at C because it's not continuous there. And in order for the derivative to exist, in order for F to be differentiable, it must be continuous. So not at C, and also here it's not continuous at E. So it's not differentiable at B, 0, at C, and at E. Let's see, what else? Okay, a couple more things to talk about. Oh, while I'm looking at this, let's just talk about if I ask you something about a particle, and if I asked you, instead of this question, this says, what's the acceleration? If I asked you, when's the particle at rest? Remember that a particle is at rest when its derivative equals 0. When the velocity equals 0, the particle would be at rest. So that's a concept that you need to know. So I didn't actually work this one out, but we did a lot of mean value theorems. So do go back and do number 50. Make sure that you can do that type of a problem. And remember, you can only use the mean value theorem if you first determine that the function is continuous and differentiable. So differentiable, that you would be able to take its derivative, right? And a normal simple polynomial function would always be continuous and differentiable. You don't need to do a proof of that. You just say, because the function is continuous and differentiable. The only ones that wouldn't be were ones that were like rational functions. So those are fractions or an absolute value type problem. Those would, get in your way, cause you trouble, square roots, stuff like that. But simple polynomial functions, things that just have powers, simple, those are continuous and differentiable. You can just state it. You don't need to prove it. The last thing I want to look at is I want to go back to this first quiz that we took, and you'll remember that we did this asked to find the average velocity, and we got time intervals that were closer and closer and closer together. And so by taking those time intervals closer and closer and closer together, we could approximate the instantaneous velocity at t equals 1. We were kind of estimating there. But if I asked you a question like this now, so if I did let's do 1a, and then let's do 1b. So 1a, when they're asking me average velocity, that's just my algebra 2 brain. So I just do the slope, right? So I would do h of 2 minus h of 1 all over 2 minus 1. And I would plug that into my calculator, get a value, and then I wouldn't forget to put my units, which are meters per second in this case, right? But part B here, find the instantaneous velocity. Well, I know this is my position function, right? So I'm calling that h for height, but you can just call it s or x or whatever you want to call it. That's your position function. That's where this arrow actually is. So I have 58t minus 0.83t squared. To find the instantaneous velocity, velocity is the derivative of the position function, so that's 58 minus 0.83 times 2t. So if I want to find it at 1, I literally just plug it in. So if I were to ask you that question now, this is the way you should do it. Again, the units are meters per second, and you should get an exact answer. You shouldn't be approximating anymore. So those are my final tips. Hopefully that helps, and good luck on your exam.